Well, hello there. Professor Sargent here with you again. This video is brought to you with inspiration from Black Pen, Red Pen, specifically this video. However, in that question, he was dealing with a special case, and I'm going to show how we can generalize his approach and develop a formula for questions of either square root of a plus square root of b is equal to c, or square root of a minus square root of b is equal to c. I actually posted a few days back an algebraic approach to this. Now I'm going to show a geometric approach. In the second case, rewriting so that I can have addition again. And here we are assuming that a, b, and c are all greater than 0 because we're talking about geometry. So what we're going to be doing is solving for the height of a right triangle and applying the converse of the Pythagorean theorem. Compute the area two ways to come up with the formula. The formula is the same for either case. What I'm referring to with regards to the converse of the Pythagorean theorem is shown in a book that I taught out of quite some time ago on page 182. Not only when you have a right triangle will you have the sum of the squares of the legs equaling the square of the hypotenuse, but also vice versa. If you have your longest side, you square that length, and that is equal to the sum of the squares of the other two sides, then it must be that we are dealing with a 90-degree angle. Now, by the way, the bit about a, b, and c being greater than 0, that's just because we're talking about a geometric approach. In an algebraic approach, it will not matter. In fact, I found in a discussion with another YouTube creator that the formula applies for complex numbers, in fact. Cautions: this is not a formula that I've ever seen before, so you may not want to go using the formula as your main method for showing work to a teacher. All right, here we go. Case 1 was that square root of a plus square root of b would equal c. So what we're looking at here is we have one right triangle on the left-hand side with one of its legs measuring square root of a. On the right-hand side, another right triangle with one of its sides measuring square root of b. So let's let this be the height of the overall triangle. And because we have 90-degree angles here, then we will have that the hypotenuse of this triangle, I'm going to write this all out and then be a little less precise in a moment. On the right-hand side, squaring the square root of a and squaring h, adding those up, and then taking the square roots. Well, that's going to be square root of a plus h squared. So similarly, on the other side, the hypotenuse of that right triangle will be the square root of the quantity b plus h squared. So we want to solve for h so that we will have this being a right angle as well. So how do we do that? Well, what we will do is, as I said, we're going to be using the converse of the Pythagorean theorem. So these two sides here would be legs. And that's supposed to equal this squared. So these squares will Cancel out the square roots here because everything's under a square root. A plus h squared plus b plus h squared. On the other side, we need to be a little more careful, applying the binomial theorem, the formula from that. We'd have the square root of a getting squared, which will just give us a, plus 2 times square root of a times square root of b, plus squaring the square root of b. Combining some like terms on the left-hand side, a plus b plus 2h squared. On the right-hand side, put the a and b in front and use the product rule for radicals. Put that together. Cancel out an a plus b on both sides, and we'll have that 2h squared is equal to 2 times the square root of ab. Divide both sides by 2. And since square root of ab, that's the same as ab to the 1/2. If I take the square root of both sides now, that would be the same as raising both sides to the 1/2 power. And we would be multiplying the exponents of 1/2 to get 1/4. So in other words, we are looking at the height being the 4th root of a times b. So now what? Now that we have a value of h that would allow us to square this leg, its length, and square the length of this leg, add them up, and that would equal the square of this side. Then by the converse of the Pythagorean theorem, we are looking at this being a right angle as well. So what we're going to do is compute the area of the overall triangle by taking this as a base and this as a height versus this as a base and this as a height. So we would have 1/2 times the c, which of course was the square root of a plus square root of b, and that's going to equal 1/2 of the square root of a plus h squared times the square root of b plus h squared. Multiply both sides by 2 to get rid of the 1/2s there. CH on the left. On the right, let's put those square roots that are being multiplied together. Square both sides. Well, c times h, that quantity squared is the same as c squared h squared. And on the right-hand side, the square roots will cancel out. Multiplying that out, we've got that c squared h squared is equal to ab plus ah squared plus bh squared plus h to the 4th. I forgot to write that back here. So h to the 4th would be ab. Let's put the h to the 4th up in the front and write that as ab. And another mistake here, that's a 2. So let's factor out an h squared on that part. So we have c squared h squared is equal to 2ab plus a plus b, that quantity, times h squared. So far, I've only done one replacement for things about h, but now let's take that a bit further. H squared was the square root of AB. So we have C squared, square root of AB is equal to 2AB plus the quantity A plus B times square root of AB again. Let's get the terms that have the square root of AB together on one side. Factor that out. Remember that A and B are positive, so A times B will be positive. The square root of AB will be positive because we're talking about the principal square root. So if I were to divide both sides by square root of AB, one, that would be legitimate to do. And when you rationalize the denominator and simplify a bit on the left-hand side, then that's just going to give us 2 square root of AB. So, let's square both sides again. Squaring on the left-hand side, for lack of a better word, distributing the squaring. 2 squared is 4, and square root of AB squared will be AB. And now we have to worry about squaring C squared minus the quantity A plus B. I'm going to treat the right-hand side like that's a binomial. C squared squared is C to the fourth. We'll have in the middle minus 2C squared A plus B and plus the quantity A plus B quantity squared. I'm going to add 2C squared quantity A plus B to both sides and subtract 4AB. Multiplying out the quantity A plus B getting squared. Combining like terms with the 2AB minus the 4AB. Then if we factor A squared minus 2AB plus B squared, that's the quantity A minus B squared. I'm going to switch the left-right order of the equal sign here. In the end, the formula that I have developed is that C to the fourth plus the quantity A minus B quantity squared is equal to 2C squared times the quantity A plus B. And in a moment, we're going to see that the second case gives us the same formula. Recall that I rewrote the second case by adding square root of b to both sides. So what we're going to have for the length of this space is the C, and the length of this base, that's going to be the square root of B. Solving for height again. So C squared plus H squared, square root of that. It's the length of this hypotenuse. And square root of B squared is B. So B plus H squared, square root of that is the length of this hypotenuse. And overall, the base of the overall triangle is the same as A. Now, you may have noticed that in the first case, having the square root of the square root of AB, in other words, the fourth root of AB, that was the geometric mean of the lengths of those two sub-bases. So here, we should expect that we're taking the square root of C times square root of B as our height. I will simplify that, however. All right, so the same process. We want this to be a right angle as well, so that we can apply the converse of the Pythagorean theorem. We're going to solve for H. And to do that, C squared plus H squared, the square root of that squared, plus squaring the square root of the quantity B plus H squared, and that should equal the sum of C plus square root of B, all of that quantity squared. Okay, so cancellation on the left-hand side. C squared plus H squared plus B plus H squared. On the right-hand side, C squared plus 2C squared B, 2C squared of B, plus the square root of B squared. That'll be B. Canceling C squareds and B's from both sides. We combine the like terms here to get 2H squared equals 2C squared of B. Divide both sides by 2. And without going into all the details that I did previously, taking the square roots of C times square root of B, first of all, we can put the C under the square root as C squared times B. So square roots of square roots, that's the same as the fourth roots of C squared of B, as predicted. Now that we have that, computing the area of this triangle two different ways, where we'll have this base times H, 1/2 of that, equaling 1/2 of the product of these two as the base and the heights. All right, so 1/2 times A times H, sorry, square root of A times H, should be square root of A back there, equaling the product of these two hypotenuses or hypotenuae from the two subtriangles on the left and the right, but now we're taking them as base and height of a larger overall right triangle. So 1/2 of C squared plus H squared times square root of B plus H squared. Multiplying both sides by 2. And on the right-hand side, putting together C squared plus H squared that quantity times the quantity b plus h squared underneath a single square root. Squaring both sides, squaring the square root of a will just give us a. Squaring the h will give us h squared. On the right-hand side, that'll cancel this square root over the whole thing. And now I'm going to start distributing, foiling things out, as we say in the United States. Again, h to the fourth there would be c squared of b. So adding that to this c squared of b. Sorry, c squared times b if I said that incorrectly. And also I'm going to factor out h squared there from the remaining two terms. H squared was c squared of b. So subtract the quantity c squared plus b, that quantity times c squared of b from both sides. Factor that out. Do c squared b remaining over here. Divide both sides by c squared of b. Again, b and c are positive. So square root of b is also going to be positive. Divide both sides by c squared of b. You're not dividing by 0. It's going to cancel the c, and b over square root of b, when you rationalize to the denominator, will give you square root of b. So what we're left with is 2c square root of b equaling a minus c squared plus b. Squaring both sides, square the 2, square the c, square the square root of b. Here, a squared minus 2a times quantity c squared plus b plus c squared plus b quantity squared. I'll distribute the 2a here and square out the c squared plus b over here. And let's see here. Got like terms. Subtract 2c squared b from both sides. Let's get a squared minus 2ab and b squared together, as well as, since we've got 2c squared b here and minus 2c squared a there, let's add 2c squared a to both sides. All right, so we added the 2c squared a to that side. A squared minus 2ab plus b squared, and that leaves us with plus c to the fourth. Okay, so we're almost there. I'm going to switch the left-right order of the equal sign for one thing, and also write the highest power here at the beginning. Factoring a squared minus 2ab plus b squared as the quantity a minus b, all of that getting squared, and now what was on the left will be over on the right-hand side. Finally, I will factor out 2c squared, and that's times the quantity a plus b. Same formula, both cases. Now we're going to apply this to an example where this is case 2. So we have that a is equal to 3x plus 3. B is x plus 10. And C is 3. Our formula was that C to the fourth power plus the quantity a minus b, that quantity squared, is equal to 2c squared times the quantity a plus b. And so the easiest part to figure out here, c squared is 9. So 2c squared would be 18. C to the fourth, then, square the 9 again, you get 81. Furthermore, figuring out what a plus b and a minus b are. Well, a plus b, 3x plus x is 4x. 3 plus 10 is 13. A minus b, we need to be a little bit more careful about. 3x plus 3 minus the quantity x plus 10. We're looking at 3x plus 3 minus x minus 10, which will give us 2x minus 7. And that quantity squared squaring the 2x, two times the 2x times the 7 is subtracted, and we will add to that 7 squared. So that's equal to 4x squared minus 28x plus 49. So what we're looking at overall then is 81 plus 4x squared minus 28x plus 49 equals 18 times 4x plus 13. Combine our like terms over here. 4x squared minus 28x. 81 plus 49 is going to be 130. Distributing on the right-hand side, 18 times 4 is 72. So 72x plus something. 18 times 13 is 234. Let's subtract 72x and subtract 234 so that we see a quadratic equation. 0 is equal to 4x squared. Let's see, negative 28 minus 72 would be 100x. Subtracted. 130 minus 234 would be minus 104. Everything on the right-hand side is divisible by 4, and 0 is divisible by 4. So that simplifies to 0 is equal to x squared minus 25x minus 26. And that factors nicely as x minus 26, that quantity times the quantity x plus 1. So either x minus 26 equals 0, or x plus 1 is equal to 0, giving us that x is equal to 26, or x is equal to -1. We're going to find that only the first one checks. 3 times 26 is 78. 78 plus 3 is 81, and the square root of 81 is 9. 26 plus 10 is 36. Square root of 36 is 6. And so 9 minus 6 does equal 3. But putting in -1 for x. 3 times -1 is -3. -3 plus 3 is 0. -1 plus 10 is 9. Square root of 0 is 0. Square root of 9 is 3. If that had been addition, then we would have had equality. It would check out, but -3 does not equal +3. So we reject this, and we only keep x equals 26. All right, that's all I've got for you. See you in the next one. Take care, stay safe and healthy.